All right, so we just did questions 1 and 2, and now we will go on and do the plan is to do questions 3 through 7 because it makes sense to do those as a group. So there are several crosses that you see here, and for these different crosses, for the parental cross, blue and red when you get purple, and blue and yellow when you get green, and yellow and red when you get orange. Um, they're all similar to number 2 because in number 2, when you have the two green tribbles crossed and blue and yellow are codominants, it's the same situation. It's the same situation going on for purple and orange. So for the first row, blue and red are codominant to give us purple. Blue and yellow are codominant to give us green. Yellow and red are codominant to give us orange. Then for the next three situations, then you see that we have blue and white, we get blue. Red and white, we get reds. And that actually should say yellow and white, we get yellow. So in those situations, every one of those colors is dominant over white. So white is recessive. In the next 3 rows, blue, red, and yellow, when crossed with black, they all are dominant over black. But when we cross black and white together, black appears over white. So what we now need to do is just write the dominant recessive pattern for each one of those. So for number 3, what that means is read the data table in which fur types are dominant. So that means that blue is dominant. It means that so blue is dominant. It means that red is dominant. And it means that yellow is also dominant. So all 3 of those alleles are dominant, and then when they're present with each other, they're codominant as well. So the next question is black recessive or dominant, and then explain. So black is recessive because when you cross the blue with the black, or the red with the black, or the yellow with the black, these colors all dominated over black. So the answer to the second part is that black is recessive. The only exception is when it's paired with white. So black is recessive except when paired with white. So in general, both the black and white alleles are recessive. The only exception is if black and white are paired with each other. So I'll just put little b is for black, and I'll put little w is for white. And then sometimes what I do is I may just put like a little dash over a lowercase letter that has a similar shape to the uppercase letter or the capital letter. So now we'll go over the other questions. So for number 4, it says, number 4 says, a homozygous purple tribble is crossed with a homozygous red tribble. So what type of offspring would you expect? Now, it is, you may have answered it in your head already, possibly, but we'll set up the Punnett square over here. A homozygous blue tribble would be homozygous B, And then a homozygous red tribble would be homozygous R. So then, if we're going to be doing the cross between those two, all of their offspring would be purple because the parents would be giving one B and one R allele. So the answer to number 4 is that they would all be purple. So that's number 4. Now, number 5. So, number 5, a homozygous. So, a homozygous yellow tribble is crossed with a heterozygous blue tribble. The blue tribble carries the recessive allele for white fur. Show the cross below. So, here we will show the cross. Okay. So, the genotypes, we have homozygous yellow. So, here is big Y, big Y. And the blue tribble carries the recessive allele for white fur. So here's the blue allele and then the recessive white. So if we fill in the Punnett square, here is BY, so that would be a green tribble. This would also be a green tribble. And then here we have a Y allele, but with the recessive white. And then we have that situation with this as well. So if we want to know the phenotypic ratio, that phenotypic ratio here would be 1 to 1. So 1 part green to 1 part yellow. So that's number 5. Now, number 6. So number 6 reads, a heterozygous red tribble is crossed with a homozygous black tribble. The offspring are 50% red and 50% black. What are the parental genotypes? So, for 6, if we have a heterozygous red tribble, well, that heterozygous red tribble could have a recessive white allele, or it could have a recessive black. We're not sure which one. It could be either. And then the homozygous black tribble, there's only one genotype that would be possible, and would be 2 of the recessive Bs. Now, we have to give the parental genotypes. Well, if we run out the Punnett squares and we see the 2 possibilities, let's check them out. So either, well, we know the black parent has to be homozygous B. The red parent could either have a red allele or that parent could have the black allele. So here that would be a red, that would be reds, that if we go back here, we say black is recessive except when paired with white. So black still appears over white. So this would still be 50% red, and this is actually still 50% black. So let's go here and let's try this one out. So here's RB, BB, RB, and BB. So that tribble would be red, this would be red, that's black, and that's black. So actually, in this case, we have something that's 50% red and something that is 50% black. So in this case, there's 2 possibilities for the red tribble, 1 possibility for the black tribble. So the red tribble could be RW or RB, and the black tribble could be BB. So then for number 7. For number 7, cross a purple tribble with a homozygous yellow tribble. Okay, so for number 7, cross a purple tribble with a homozygous yellow tribble. So we'll set up that Punnett square here. The purple will have 1 R allele, 1 B allele, and then the yellow will have 2 Y alleles. And then here, just fill out the Punnett square once again. So we have RY, RY, BY, and BY. So this would be the genotype RY for a triple that's phenotypically orange, and then I'm sorry, and then this would be green and that would be green. So the probability of a green offspring is 50%. So I'm going to pause that there before I go to the next set of problems.